Right, our beginning is actually to focus on question 4. Given
Okay.
given the exponential function g of x, which equals a half to the power x, write down the range of the function g. What is the range of the function g? Okay, so we know that we are focusing on question 4 right now. Question 4, but to be actually more specific, we are focusing on part 4.1. And now focusing on part 4.1, what is the range of this function? So it's actually the set of y values. But most importantly, it's necessary to realize that the range of the function g of x, which equals 1/2 to the power x, this range is consists of all y values greater than 0, strictly greater than 0. If you don't want to say that, because that is the exponential function, or you can say it consists of all the y values that are from 0 to infinity. Okay, so that is the exponential function of the required form. What form would this be? So it is any form y equals a to the power x. It will have the range, this one, y greater than 0 strictly, or the open interval. Call this the open interval with the round brackets, and therefore it is actually our range there. Okay, in 4.2, write down the equation of G inverse in the form y equals something. Okay, what is the inverse here? Okay, so we are looking now at 4.2. Right, so to write the inverse function, what do? We do the following. So we write G, and then we write y equals 1/2 to the power x. Then the next thing is we write G inverse, and G inverse will have the x and y with their roles reversed. So we reverse the roles of the x and y in the inverse notation. And then from there, we are actually making y the subject of the equation. And now making y the subject of the equation would therefore mean that y is therefore equal to the logarithm of x base 1/2. Okay, so that is what we do. X base 1/2. This this is the log function, but this is can be written differently. So if you want to write like this, you can write y, goodness me, is the logarithm of x base 1/2. Right, so you can write x base 1/2 which is the log of x divided by the log of 1/2. So this is the log of x, which is the log of 2 to the power minus 1. You can write 1/2 like that. So with that, you can write, for example, the log of x. We can bring the power -1 in front, like that. In which case, therefore, this can be written as minus the log of x divided by the logarithm of 2, which is the logarithm of x base 2. Now, this is it. Y equals the logarithm of x base 2. Okay, so that's what you have. Y equals the logarithm of x base 2.
Why do we use log?
Okay, why do we use log? Okay, that's a good question. Why do we use log? We use log because the inverse of the exponential function, okay? The function g of x, which is of the having the equation y equals 1/2 to the power x, is actually an exponential function. And so now the inverse of the exponential function becomes the log function. Okay, so it's sort of the principle we use. But how do we convert the g, which is the exponential function, to the log function? How? First, we write the following. So we write y in the place of y, what we say. So y is replaced by x. Okay, so but also x is replaced by y. So we switch the roles of x and y in the G inverse notation. And then to make y the subject, we just write the following. We just write y equals the base of the power. So we have the base of the power. What is the base of the power? This here is the base of the power. And this is the exponent. So now the base of the power becomes the base of the log. Okay, so we are done there effectively. Once we write that, we're done. But we can play around with the log because some students might have been taught to simplify the fraction in the log, like 1/2 can produce a negative like that. But this here is optional, so which means that we can decide not to do it. Okay, all right, we shall discuss logs a little bit more, the logarithm a little bit more. Okay, but yeah, just take note of that. That is the inverse of the exponential function is the log function. So this one is called the exponential function. Right, so we are looking at 4.3 right now. And now the question there is G inverse a function? Justify your answer. Okay. So is G inverse? Yeah, is G inverse a function? So let's answer that one. All right. So we're looking at 4.3 now. Okay. Now there's something. So now the graph of the inverse function is sketched like this. So now we realize that it is sketched like this. So this is the graph of the function g of x, which is 1/2 to the power x, sketched like that. Right, because in mathematics, when the graph, for instance, is of the function y equals 2 to the power x, then it becomes a function you call increasing. This function is said to be decreasing. Why is it decreasing this function? It is decreasing because when x increases, the function is going down, and therefore it's a decreasing function. Okay, what is the inverse function? We saw that the inverse function is having the equation, this one here. That is the inverse. That is the inverse. So the inverse of the exponential function is the red function, which is the log, the logarithm. Okay, the logarithmic function. Now, what is the graph of this logarithmic function? And how can you draw the graph? Okay, it's easy to draw the graph of the inverse function, because if you can draw the graph of the original function, what you do is you draw what we call the, try to pay attention, this is a little bit tricky to some students, the functions. So you try to do this. And then after that, you say, what is this? So if this one is the point with coordinates are 0 and 1, the inverse function, which is the mirror image, will actually switch the coordinates. So it will switch those 0, 1 point to 1, 0 point. 1, 0 point. Once it switches the 1, 0 point, we have this. Okay. So which means, yes, which means that the point that is here is going to be there. Now I'm trying to draw the graph. They did not ask us to draw the graph. They did not ask us to draw the graph in 4.3, but I'm just I want to elaborate on the answer. So now, after this, then we can be able to draw the graph of the function. Okay, so we realize, therefore, that if you have 1 point, it's there. What other point can you pick? But also the function is going to also be here, right? So you basically have, say, 2 points there. All right, we have 2 points there. And now, what can then be the graph of this function. So look at that very carefully. And we're going to just draw the graph just now. Okay. They did not ask us to draw the graph, but I'm just drawing the graph so that we learn something together. Right, so now I want you to realize that you already have 2 points. So the function will have to connect the 2 points like that. Okay, so this is sort of this is sort of the graph you're going to get. Okay, this is sort of the graph you're going to get. Because now the graph is going down like this, and then now you can see it's getting closer to the x-axis here. When you continue, it's getting closer. So the mirror image is going to be getting closer now to the y-axis because so now the purple one will be the inverse function, and the green one is going to be the original function. Okay, graphs and functions can be a bit technical, so you need to pay particular attention to this. Why am I even drawing this graph? Because the examiner did not even ask us to draw this graph. I want to bring to light the concept. So the examiner is saying, is G inverse a function or not? So to know if it's a function or not, we need to draw a vertical line through it. We're going to draw a vertical line. Let's just draw a vertical line. Like this. Looking at the purple graph, you can see that the vertical line cuts the purple graph at 1 point only. So yes. Yes, so the answer is this one. What is the answer? The following is the answer. What is the answer? Yes, vertical. So the vertical. The vertical line test. Cuts G inverse once. There's a vertical line test. So this vertical line test cuts the graph of G inverse, or cuts G inverse once. So what is the answer to question 4.3? Is the inverse a function? So the answer is the blue one. It's not everything else I've done. I've just elaborated. So the elaborations are just there to help us understand this a little bit more. Okay, let's look at 4.4. Now, there is a point, M, whose coordinates... So we're looking at 4.4. The point M, then you look at 4.4.1. The point M has coordinates those. Okay, let me just note that and not write it down. The point M whose coordinates are A and 2. This point lies on the inverse. Calculate the value of what? Of A. We must write down the equation of the inverse. We remember that the inverse is given by what? We remember that G inverse is given by y equals the log of x space 1/2. This we remember very well. Okay. From the previous question. So, if this is true, then there is a point M. There is a point M, and this point M has x and y, which means y is 2. The log of what? The log of what is x? X is A, base 1/2. So this is 1/2 raised to the square equals A, which means A equals. So what is 2 to the minus 1? Well, you can write like that, but there's no need to do this. So, well, which means that you square 1, you get 1, you square 2, you get 4, which means they will ask us to find the numerical value of A, or just the value of A, and therefore the value of A is just exactly 1/4. Now we move on and we solve the next question. We look at 4.4.2. M primed, the image of M lies on G. Write down the coordinates of M primed. Right, so M primed, which is the image of G of M, lies on G. Write down the coordinates of M primed. Right, so now to write down the coordinates of M primed, you need to know the coordinates of M. So the coordinates of M are, we saw that the coordinates of M were given like this. They were given as A and what? And 2 in the question. And this was M. A was 1/4 and with 2 there. So what is M primed? So M primed will therefore have coordinates. You switch the coordinates around because these are inverse functions. So if you switch the coordinates around, because it's what the inverse function does, so which means that 2 is written, the M primed is written as 2 and 1/4. Right, so that's what we get.
Okay.
So the next thing is now we look at the next question. The next question is, so the answer is actually what I've written there. It's M primed with coordinates 2 and 1/4. Now, we have 4.5. Now, if H has coordinates, rather H of X is G of X plus 3 plus 2. Write down the coordinates of the image M primed on H. Right, so now we have this one for 3 marks. We have this one for 3 marks. We have that H of X is G of X plus 3 plus 2. Write down the coordinates of the image of M primed on H. On H. What are the coordinates of M primed? Well, we know that the coordinates of M primed are as given there. But I want to write them on H. So what is H gonna do here? So H has X plus 3. What does X plus 3 do? Well, it's a transformation of the function. So it means 3 units, 3 units left, 3 units left. That is what the plus 3 means. So if you see plus 3, it means 3 units left. So if it's 3 units left, then we have 2, and then you subtract 3 like this. And then you have 1/4. Now, so the X plus 3 only affects X. Now you have the other coordinate 2. So if you have 1/4, you move it up, you add 2. 2 units up. So which means the coordinates of M primed will be, what is 2 minus 1/3? 2 minus 3 is actually minus 1. Now you're adding 1/4 to 2. What is 1/4 plus 2? Well, you can take the LCD here, lowest common denominator, and then you have 4 divided by 4, 1 by 1, 1 plus. So this out of 1, 4 divided by 1 is actually 4 by 2, 8. Which means M primed, which is minus 1, and then it is 9/4. So that is the answer.
Okay.
Right, so now we would have that the answer is written like that. But why are we even doing all this? We're doing all this because of what the examiner has done in the question, because the examiner has performed some transformations of the function, has said, okay, now we are having X, but we're adding 3 to it, but also, so we're transforming this, but this means if we're adding 2, it means 2 units. 2 units up. 2 units up or 2 units upwards. Okay, right, so you're getting that. Now we are done with this question and we get the 3 marks there. Okay, right. We are just speaking a little bit about graphs and functions because they are very, very examinable and will be coming in our trial exams very soon. Okay, the trial exams are just around the corner. Let's just look at the rectangular hyperbola because it is also a very, very examinable and it's going to be appearing in our trials now, trial exams. Right, so our next focus is question 5. And question 5 is very, very interesting. Right, very, very interesting because it is very examinable. So we're going to look at 5.1.1. Determine the equations of the asymptotes of f. What are the asymptotes of f? So you get the asymptotes by considering that. So for the asymptotes, you let x plus 2 be 0 in the denominator, and then you actually let y be equal to 3. So which means x is minus 2, and the other one is y equals 3. So we have those two asymptotes. These asymptotes are specific names. So the x equal minus 2 is called the vertical asymptote. And then this one for y is called the horizontal asymptote. Horizontal asymptote. All right, so that's what we get. Okay, so we continue. We continue. Right, so we move to the next question. Right, so if you say in 5.1.2, write down the y-intercept of f. The y-intercept of f. F is the rectangular hyperbola. What is the y-intercept? So we remember something now. We are looking for the y-intercept. How do you deal with the y-intercept? You let x be 0. So which means if you have f of x equals 1 divided by x plus 2 plus 3, which means for the y-intercept now, you're going to do what? You're going to let x be 0. You're going to let x be 0. So wherever there is x, you put 0 in the function. So this is 1/2 plus 3. The LCD is 2. Divide 2 by 2, you get 1 by 1. 1, 2 divided by 1 is 2 by 3, 6. And then this is 7/2. 7/2. So right, so we'll continue. And therefore, if they say if then they say what is the 5.1.2, return the y-intercept of f. So the y-intercept is going to occur at the point where x is 0 and y is 7/2. So what is the y-intercept? Is 0 and 7/2. Okay, so we have answered 5.1.2 and we proceed to look at 5.1.3. Calculate the x-intercept of f. X-intercept of f. How do you find the x-intercept? So now we look at that one. Right, so in 5.1.3, we're going to proceed like this. We're going to proceed like this. So for the x-intercept,
Y equals 0.
well done. You let y be 0, isn't it? Okay. Thank you so much for realizing that. So that we have the function, we just write down the function. So the function is this one, which is x plus 2 plus 3. We have that y is 0. We divide everything by x plus 2 plus 3. So, which means you have minus 3, you divide by x plus 2. So at this point, you cross multiply, which means minus 3 into x plus 2 equals 1, which means minus 3x minus 6 equals 1, which means minus 3x equals 1 plus 6, which is what? Which is 7. Right, so we divide it through by negative 3, which is minus 7 over what? Over 3. Right, so we good now. And what is the x-intercept? So, which means the x-intercept is given by what? Is given by x equals minus 7 out of 3, and y is what? Is 0. Okay, so that is what we have there. We continue with our discussion, and we look at 5.1.4. Sketch the graph of f. There we're going to do the sketch of that one in 5.1.4. So sketch the graph of f. Clearly label all intercepts with the axes and any asymptotes. Right, so let's look at the sketch of the graph. So we're going to sketch together. So here is the vertical axis, and here is the horizontal axis. And then we're going to proceed to sketch. We have the vertical asymptote through minus 2. And then we have the horizontal asymptote, which is through through 3. It is 3 there. Right, so we have this. We have this sort. Now, we then say, what are the intercepts with axis? Like this one is your y and this one remains our x-axis. So let's look at the x-intercept with that. What is the x-intercept? Like the y-intercept is at 7 over 2, which means that if you divide 7 by 2, you get a 3.5, okay? So now you have 3.5 for the y. So you are here and you have a 3.5 there. So the graph is going to be doing this here. And then you have this one, which is minus 7 over 3, minus 7 over 3. Obviously, it's somewhere here, because it is the same as approximately. It is the same as minus 2.3. So minus 2.3, you're going to sketch like this. So now, this is the graph. What are these things here? We need to sketch the graph and show all intercepts with the axis. We have shown the intercept with the axis. You can show it like this, but also you can demonstrate it like this, minus 7 over 3 and 0. And here you can demonstrate it like this. You can say x is 0 and y is 3.5. 3.5. You can write a comma, a point, comma, yeah, notation. Right, so you have this. So that is the answer. And this becomes the origin of the plane. All right, so we continue. We're done with the sketching. Okay, I want to comment on the sketching part, just so that, because of your background at school, right, so there are always two kinds of hyperbola graphs we learn at school, and we need to just to make sure that we understand those. So there's always one parabola graph that sits in the first quadrant and sits, this is the first, the second, the third, and the fourth. It sits in the first and the third quadrant, or it sits in the second and the fourth quadrants. Okay, right. So now there are a couple of things that are very important. So now at this point, if this is true, and the graph is like this one is always of the graph y equals a over x, where a is positive. If the numerator is positive, then you have the graph like that. But also you have this case here, where y is a over x, where a is negative. Okay, so now you have a point where a is negative. So if a is negative, then you have that it is in the other quadrants. So this is the first, the second, the third, and the fourth. So if a is negative, examples of the negatives would be a -1, for example, in the numerator, or a equals a -2, a -3. So the graph is going to be sitting here and there. Otherwise, the graph is going to be sitting in the first and the third quadrants.
Okay.
We continue. Right, so good. I'm just recapping on some of the basics on graphs, on the rectangular hyperbola graph. Okay, right. So in 5.2, we are now in a position to discuss a sketched graph. Right, let's look at this one that is sketched for us. Now, below the graphs of K, and K itself is this one, and H is that one. Right, graph K has turning point at -1 and 18, and S is the x-intercept of H, and also we have something and K. So S is here. It is the x-intercept of the two graphs because both graphs cut the x-axis at the point S. Right, graphs H and K also intersect at T. Okay, the two graphs can see T is the point of intersection of the two graphs. Right, so now in 5.2.1, let's look at what the examiner wanted in this exam question. Right, there are lots of practice things we're going to do to make sure that we learn, we continuously learn, and we become better at learning, and we become better, we get the level 7 we desire, okay, to get into varsity, and so on and so forth. Okay, so calculate now the coordinates of S. Right, so find the coordinates of S is very straightforward. How do you find the coordinates of S? So look at 5.2.1. Right, you can take the function whose equation is known and then find the x-intercept. So it is the x-intercept. And to get the x-intercept, you let y be 0. So if h is -2x plus 4 and y is 0, which means we have 2x equals 4. You divide through by 2. So, which means that when x is 2, then y is 0. And these are the coordinates of S. So the coordinates of S are those ones. What are the coordinates of S? The coordinates of S are clearly 2 and 0. Right. Now we look at the next one, 5.2.2. Determine the equation of K in that form that. Determine the equation of K in the form that for a total of 3 marks. Right, let's look at that one. 5.2.2. Right, so now to do that, the equation of K, so we are actually looking for the equation of K. which means we have y equals this, plus p plus squared plus q. So we have the turning point, TP, the vertex, which is -1 and 18. P and Q. This means y would be a into x, like this. Okay, I've just taken exactly the equation given there. So which means at this point you'll have what? You have plus. So it's plus P plus P. Right, so if it's plus P, what should it get? So it must be a +1. Okay, because if it's negative, then you make it plus. So it's just that. This one is Q. Q is 18, so that one you take it with its sign. Right, so we have these. Now we need to just find the value of A, and then we just need one extra point. So we're going to use the point S on the graph. In the point S, we already know the coordinates, and the coordinates are 2 and 0. They're 2 and 0. Okay, so we continue. We continue with ease. We continue with ease. Continue with ease. Right, so we are in business. So now, for instance, it is passing through a point, this, okay, so through S with coordinates 2 and 0. So you have X and Y. So which means Y 0. X is 2 plus 1, you square it, plus 18. What is 2 plus 1? 3, you square it, it's 9a plus 18. So what is this? Which means you have 9a equals minus 18. Divide through by 9 and you get -2. Right. Okay. So you continue. All right. Continue. And so now we continue. So
Yes.
what is the equation of that is required? So it is exactly y equals. So what is A? A is -2, and you substitute it into this equation. So A is -2 into x plus 1. Then write x plus 1, and then you square it plus 18. So that is the equation in the required form. In the required form, the one I'm encircling in red, so it is exactly of the form the examiner wanted there, and you get the 3 marks there. Okay. We continue. Right, we look at the next one, the next question. What is the next question? 5.2.3, we have that k of x equals -2x squared minus 4x plus 16. Determine the coordinates of t. 5.2.3. Right, so in 5.2.3, if k of x is this, determine the coordinates of t. Right, to find the coordinates of t, It's easy. What is T? T is the point of intersection. So we are finding the coordinates of the point of intersection. So T is a point. Is a point of what? Of intersection. Right, so if T is a point of intersection, what does it mean? It means the two functions are equal to each other. So it means that K of X is equal to H of X. What is K of X? Well, we saw that it is minus 2 into X plus 1 all squared plus 18. And then the H is the same as what? Minus 2X plus 4. So you have minus 2 into, you square this one, which is X squared, plus 2X plus 1, plus 18, which is minus 2X plus 4. Minus 2X squared, minus 4X, minus 2 plus 18, which is minus 2X plus 4. So we have minus 4X minus that. So we have minus 2X. You bring down the other minus 2, it becomes minus 2X, and then this becomes plus 12 if you subtract 4 equals 0. We divide through by negative 2, which means that we have X squared plus X minus 6 equals 0. We can get the binomial factors, the linear factors. So, which means the factors of X squared are X and X. The factors of minus 6 are actually 3 and negative 2 because the middle term is positive. So 3 is bigger. It must take the sign of the middle term. And therefore, we have that X is negative 3 or X is 2. So what is this now? We want to determine the coordinates of T. So at the coordinates of T, we have that X is negative here. X is less than 0. So we have that at this point, we can see already X is minus 3 because we have the 2. The 2 applies to other point of intersection S. So now we just need to find the corresponding Y value. Right, so the two graphs intersect, and therefore we can just pick the easiest one to deal with, which is the linear function. So the linear function, which is minus 2x plus 4, we substitute x, which is negative 3, which is 6 plus 4. What is 6 plus 4? 10. So which means that x is minus 3 and y is what? It's 10. So these are the coordinates of the point T. These are the coordinates of the point T. So in 5.2.3, we have that x is minus 3 and y is 10. These are the coordinates of T. All right, so we're done. Now the next question is 5.2.4. We need to determine the values of x, for which k is strictly less than h of x. It means k is below the function h. Let's see that one. For in 5.2.4, we need the value of x for which k is less. Look at the two functions. This is k, the parabola, and h is the straight line. Where is the function h smaller than, where is the function k smaller than the function h? Where is k smaller than h? Right, well, you can see that k is smaller when, what happens when k is below? But here we can see that k is above here. So we're interested in the part where k is below. So k here is below. So this is k is below h. So this one continues and that one continues, but you can see that even here k is below. So we have these. The coordinates are, we have seen already, the coordinates are -3 and 10. So yeah, that we know for sure. So which means that when x is less than -3, when x is less than -3, so when we just are moving a little bit in that direction, x less than -3, we can see that the parabola is below the straight line. Or here we can also see it's below the parabola. So that happens when x is bigger than 2. Okay. So it's when we just migrate to the part of the x-axis where x is strictly bigger than 2. Okay. You continue. Right, we're practicing here. Graphs a little bit, and we're moving on to other topics. Right, so now if it is further given that k is the graph, if it is further given that k is the graph of G primed, okay, now you are told something new. If it is further given, so there's more additional information about this. So in 5.2.5a, if it is further given that k is the graph of G primed, if it is further given that k is the graph of G primed of x, so which values of x will the graph of G be concave up? Right. Yes, please. Okay, so let's analyze this one together. Okay? So we're analyzing this one together. Now, we are told that it is given that k is the graph of G primed. So in other words, we are told that k of x is G primed of x. All right, so, but they're just interested in us to saying, okay, for which values of x will the graph of G be concave up? Well, the graph of G will be concave up at the point where we have that x itself is less than -1. X, if x itself is less than -1, so in other words, you are looking at the fact that from that part of the graph, you have that this one here, you have less than -1. In the part where you have less than -1, it follows that therefore the graph of G will be concave up. So, because you really can see the shape of the graph. The graph is facing down. And therefore, if the graph of K is facing down, it actually obviously means that the graph of G primed itself will therefore be concave up. Think about that. So spend some time on the concavity of graphs. Okay, if you look at part B, sketch the graph of G showing clearly the x values of the turning points and the point of inflection. Okay, let's sketch the graph. So we are looking at 5.2.5 part B. We need to sketch the graph of G showing clearly the x values of the turning points of the point of inflection. Right, so to sketch the graph, we're going to do this. You have your Cartesian system. You have y and x. So now it follows at this point that your graph is going to be somewhat like this. And then you're going to have these parts here. Which is -1. And then this one is going to be g. X-axis there. So you can see what is happening here. That this is going to be the graph of g. So you're going to see that this is the turning point and this is the turning point of the graph. But now you can see that wherever this graph of g of k now is 0, when y is 0, the graph is going to have a turning point. So at 2, you have a turning point. But also at this point, you have the intercept to the axis. And now it is -4 here. The graph of g is going to have a turning point as well. So, you need to also show clearly the x values of the turning points and the point of inflection. Right, so the point of inflection would be at the point where the second derivative of g itself is equal to 0. And this one is going to be the point of inflection. Point of inflection. All right, so we have a good idea. Good idea. But we're going to continue. This is the graph we wanted. And now for 3 marks, we're done. Next is question 6. So question 6. Okay, question 6 is about what? More learning, more graphs. It's about sun delay. Now, question 6 is about sun delay, and sun delay is very exciting. Sun delay bought a car for 180,000 Rand. The value of the car depreciated at 15% per annum according to the reducing balance method. The book value of Sandile's car is currently 79,866 Rand and 96 cents. Okay, we make the observation that in 6.1.1, how many years ago did Sandile buy the car? How many years ago did Sandile buy the car? Right, so let's look at this one. Well, the reducing balance method tells us that we have A equals P into 1 minus I to the power n. Okay, so we make the observation, therefore, that at this point we have 79866 0.96, which is 180,000, which is 15% per annum. If 15% you divide 15 by 100, you get 0.15, and you raise it to the power n. Right,
We're
so
going to use log.
yes, thank you so much. We're going to use the log. I'm glad that you're able to see that, right? We're going to use the log. Okay, so we're going to divide by 180. So we have 79866,96. Divide by the log, which is 180, 123, which is, okay, now you can have 1 minus 0.15 to the power n. Okay, now we have an exponential function. We need to solve for the exponent, and then we introduce the log. So already a couple of ways to write that one. So we can do it like as follows. Introduce the log, you take the log on the left. 866,96. Then you have 180, 123. And then you take the log on the right. Which is 79866,96. Which is 180, 123. Which is n, the log of 1 minus 0.15. What is this? So we divide both sides by the other one. So you have 79866,96 all over 180,000 all divided by, okay, divide by the log of the right hand side, which is that equals n. Okay, so we're going to use our calculator to simplify this. If you use your calculator, then this is about 4,999 years. So what is the answer to this? Well, the answer to this is that n itself is approximately 5 years. So it took approximately 5 years for the book value to become that. How many years ago did Sandile buy the car? So Sandile bought the car approximately 5 years ago, 4.999 years ago. In the next question, 6.1.2, we're looking at exactly at the same time that Sandile bought the car, Anil deposited 49,000 into the savings account at an interest rate of 10% per annum, compounded quarterly. Has Anil accumulated enough money in his savings account to buy Sandile's car now? Let's look at 6.1.2. Right, so in 6.1.2, we're looking at financial mathematics. First and foremost, we understand a couple of things. That exactly the same time that Sandile bought the car, Anil deposited 49,000 in a savings account at an interest rate of 10%, compounded quarterly. Has Anil accumulated enough money in his savings account to buy Sandile's car now? So we're dealing with a compound interest situation, but appreciation in value. So which means, therefore, we have 49,000 by Anil that is deposited into a savings account. The interest rate is 10%, but is compounded quarterly. 10% to divide by 100, it becomes 0.1. This compounded quarterly, there are 4 quarters in 1 year. Then we can see that in 5 years, they're going to be 4 quarters by 5 years. So which means that if you use a calculator, we shall see therefore that this will actually be exactly 80,292,21. So what is the meaning of these? Well, we can see that it's 80,000, but currently the car costs 79,000. So with 80,000, you can buy it. You can buy the car. So which means therefore the money will be enough to buy the car. The money will be enough to buy the car. Okay. Because the 80,292,21 is actually much larger than the book value of the car and what the car is worth, because now the car is only worth 79,866.96 So which means that, hey, at this point, the money will be very enough. 80,000 is more than what the car costs. It costs only 79,000. So with 80,000, surely we are sure that Anil can be able to buy Sandila's car now. Has Anil accumulated enough money in his savings account to buy Sandila's car now? Yes, he does. Okay. So we're looking at the next question. Right. So 6.2. Then looking at 6.2.1. Exactly 10 months ago, a bank granted Jane a loan of 800,000 at an interest rate of 10.25% per annum compounded quarterly. The bank stipulated that the loan must be repaid over 20 years, must be repaid by means of monthly repayments of 7,853.15, starting 1 month after the loan was granted. So in 6.2.1, how much did Jane owe immediately after making the sixth payment? So let's look at this one. These are called ordinary annuities. So this is an ordinary annuity. Ordinary annuity suggests that the payments start immediately after. The payments start immediately after a given period. The payments are ordinarily not immediate. So now, what is this? How much did Jane owe immediately after making the sixth payment? So now we need to look at these carefully. That we have a timeline like this. Okay, so this one's are best done with things we call, we use the tools we call timeline. So timeline now will have time 0, time 1, time 2, time 3. Then you have, remember, it must be repaid over 20 years. So which means that you're going to have but now these things are actually compounded monthly. So which means you're going to have 20 years times 12, it's like 240. 240 months. And then this one is right, 240, then 239. Then this one is 238. And so on and so forth. Okay. What is the meaning of all this? This is called a timeline. So exactly 10 months ago, a bank granted Jane a loan of what? 800,000 in interest rate of 10.25% compounded monthly. The bank stipulated that the loan must be paid over 20 years, 240 months, must be repaid by means of monthly repayments of that one starting 1 month after the loan is granted, or not annuity, just 1 month after it's granted. How much did Jane owe immediately after making the 6th payment? Right, so now these payments here is going to be exactly 7853,15. Okay, these payments like go on, they continue, they like perpetually are made. It is 7,853.15. Now look at this. After making the 6th payment, how much did Jane owe? So in other words, we're looking at present value. Present value is x into, is at the back of the exam paper, 1 plus r to the minus n divided by the interest rate I. So which means that the present value is exactly 7853,15 into 1 minus. Okay, what is the interest rate? It's 10.25, but you divide it by 100. So it's 1 plus 0.1025. Okay, it's monthly divided by 12. So which means that you have a total of 240 months. But after making the 6th payment, so you're going to have T5, T6, and then you go on like that. So the question, therefore, is how many payments will therefore be outstanding? How many payments will therefore be outstanding? So the payments that will be outstanding will be 234. Will be 234 payments. Obviously, 234 payments after making the 6th one. So we are looking at the payments from the 7th payment onwards. Just at 234. So which means that you have minus 234. Okay. Divide everything by 0.1025, you divide by 12. What is the present value? Use a computer calculator. So using calculator tells us that you'd have 793,749,25. This means that it's 793,749,25. So this tells me how much did Jane owe immediately after making the 6th payment? This was the amount that was outstanding. Okay, it was exactly 749,749,749.25. Okay, if you don't want to do the calculation like this, because this is one way to do this, but we have another way of calculating balances in the matric exams, and this is another alternative way to do it. Do you want to use the present value formula? You can use the future value formula. Right, so you say in metric exams, the balance outstanding. So the balance outstanding is equal to, so we know very well that Jane took a loan of 800,000, so you're going to say 800,000. Right, so you add, you have the 10.245%, you divide by 100. 0.10. 12. So it's months, 6 months. After making the 6th payment, how much will Jane be owing? So now you realize that Jane was making those payments of 7853.15 into 1 plus. The interest rate was the 10.25% by divided by 100, so it is 0.1025 divided by 12. So it's after making the 6th payment, divide by 0.1025 divided by 12. Okay, so here's what you get. Using calculator, you get 841,885,56 minus 48,136,62, which is 793,748,94. So in other words, we got something similar to this. In the previous method, using the previous method of the present value, we got 793 and also got 793, just default by a little bit of sense, but these are the two methods we use to do the calculations here. Okay, so to find the balance, we either use the present value formula or we use the balance outstanding formula, which uses the future value formula here in the appreciation formula, where we have the 800,000, etc. Okay, now let's continue and look at the next one. So in 6.2.2, due to financial difficulties, Jane missed the 7th, the 8th, and the 9th payments. She was able to make payments from the end of the 10th month onwards. Calculate Jane's increased monthly payment in order to settle the loan in the original 20 years. Now, Jane is having some financial challenges and it's not having the money that's required at the right time. So we can see that Jane missed, okay? Jane made the 6th payment, but Jane missed something. What did Jane miss? Jane missed the 7th, and then the 8th and the 9th. Okay, let's look at the timeline. Let's just see what's happening here. So you have the timeline like this. So this one is time 0, time 1, time 2, time 3. Okay. 20 years, monthly, you have 240 periods, payments that are required. 239 here, and then here it's 238, and so on. Okay, so you have the middle, intermediate payments then. Okay. Due to financial difficulties, Jane missed something. Like the 7th was out. So you have, okay, need to just to jump a little bit here. Right, so you have the 7th, you have the 8th, you have the 9th. Okay, all of them are in red. No payment, no payment, no payment. She was able to make payments from the end of the 10th month. Oh, now we have T10. Now T10 is beautiful and it's green. Now Jane is back to the good books of paying. Okay, but we remember that at T6, Jane was able to pay. Yes, T6 was able to pay. Okay, but there was a jump there. Okay, from T3 to T6, there were payments there. Okay, but yeah, not shown on the line, on the timeline. Right, so calculate Jane's increased monthly payment in order to settle the loan in the original 20 years. Now, Jane was supposed to increase the payments a little bit. By how much would she increase the payments now that Jane is supposed to settle the loan in the original 20 years? Right, so the couple of things obviously you need to consider here. You would realize that after making the sixth payment, Jane was owing 793,000. So which means the time that Jane was not making the payments, this 703,000 was also increasing. So if you don't pay the debt, you don't pay your car, you don't pay your house, you jump the payments, then they're gonna increase. You're gonna owe more and more if you decide not to pay, or there's some challenges because you can't pay, you know what the challenges are, and then you're gonna owe more and more because this interest and the debt grows. So the 793,000 that we got here after making the sixth payment, this is what she was owing, and then now it is going to increase to the following. To increase to 814, 263, 3052. All right, so there's a new installment. What is the new installment? What is the new installment? The new installment is going to be obtained by using the present value, which is p equals x into 1 minus 1 plus I to the minus n divided by I. Which means you have 814,263, 3052, which equals x into 1 minus 1 plus 0,1025 divided by 12, it's monthly. So the new installments now, you'll have a total of minus 2, 31 payments divided by 0,1025 divided by 12. So you'd have minus 231 payments because there were some jumps of 7th, 8th, and 9th payments. So there were 3 payments that were jumped. Okay, they were omitted, 3 payments that were omitted. So the 3 payments that were omitted will lead us to 231 because you remember that we had 240 altogether. And then from 240, you minus 6 of the payments that are done successfully. And then that gave us 234. And then now we have 3 omitted payments, and then it becomes a 231. for x which is exactly 80,000, 89, comma 20. 8,089 rand and 20 cents. So these will be the increased payments. If this amount of money is to be made, and now is supposed to pay the money in the prescribed period of 20 years. Okay, so we have that. Now let's look at a little bit of calculus and enjoy ourselves more mathematics. Right, so now let's practice and look at question 7. 7.1 is calculus. Right, so if you have that h of x is this one, determine from first principles, determine f primed of x from first principles. So now we're going to write down first the formula. F primed of x is the limit as h tends to 0, h approaches 0 of f into x plus h minus f of x all divided by h. So this is this. The limit is h tends to 0. So this is x plus h square root plus 2 minus what is f of x? It's x squared plus 2. We divide by h. Which means f prime of x equals the limit. So you square this, which is x squared plus 2 xh plus h squared plus 2 minus x squared. Okay, so you have this. So you have the cancellation of the terms, and then we put out a common factor, and then we have 2x plus h divided by h. So is the limit as h tends to 0, which is 2x plus h. As h tends to 0, it is 2x plus 0, which is 2x. So which means the result is 2x. The result is 2x. So we have determined f primed of x from first principles in 7.2.2. Now you need to determine dy dx if that is the case. Right, so let's continue and do 7.2.1. We want to find dy dx using the laws of differentiation. So with 7.2. So we have this over x, which means y is 4x cubed plus 2x to the minus 1. And then now you can find the derivative of this, which means dy dx is 12x squared minus 2x to the minus 2. Right, because 3 by 4 is 12. Then 3 minus 1 is 2. So we have that. And then now you need to leave your answer with positive indices. So you have this one minus 2 over x squared, and this is the result. Now we continue. So the next thing is to look at 7.2.2. 7.2.2, we have y equals 4 multiplied by the cube root of x plus, open bracket, 3x cubed, and you square everything. Square everything. Okay. What is this? This is y equals 4 x raised to 1/3 plus 9x to the 6th power. Now you find the derivative of this. dy dx. So this is 4 over 3x. 1/3 minus 1 is minus 2/3. 9 by 6 is 54. 6 minus 1 in the exponent, we have 5. So which means dy dx. Write like this, but we can write it with positive indices. So this one you can write it as x to the 2 over 3 plus 54 x to the power 5. Okay, so we have done 7.2.2, and that is the result there. That is the result. So now we proceed to look at the next question about the linear function g of 1 equals 5 and g primed equals 2. Let's look at that one. Right, so in 7.3, if g is a linear function with g of 1 equals 5 and g primed of 3 equals 5, determine the equation of g in the form that. Right, so in 7.3, there is a point of contact. Point of contact. X is 1 and y is 5. And so this m primed equals 2 means that the gradient is 2. And therefore we can use y minus y1 equals m into x minus x1, which means y minus. You can use the point of contact. This point of contact is going to have two things, x1, y1. y1 is 5. x1 is 1, so y minus 5. This is 2x minus 2, which means y is 2x minus 2, you add 5, which means you have 2x plus 3. That's the answer. So they say determine the equation of g in the form y equals something, and here it is. It is exactly in this form there. Now we look at the next question. The next question is about the cubic function, this one. H cuts the x-axis at -3, 0 and the other points. Show that H is given by that one. Let's look at this one carefully. Question 8 now. Right, so we are looking at the solution to question 8. 8.1. Okay, so we have the cubic function. That one cuts the x-axis at those 3 points. show that h is that one. Right, so the couple of things you need to consider. That the function h of x is given by minus 2 x cubed plus bx squared plus cx plus d, which means h of x is minus 2 into x plus 3 over 2 x minus 1 x plus 3. You can write like that. Okay, so we're using x plus 3, so you minus, so you take the opposite of this with x. Right, so you have this. The minus 2 here is exactly this here. So you have 3 over 2, and then you have x by x, which is x squared. Multiply this is going to be plus 2x minus 3. Multiply everything, which means h of x is minus 2 x cubed minus 7x squared plus 9. That's exactly what they said we had to show there for 3 marks. Okay, so now we continue and look at the next question, 8.2. Calculate the x-coordinates of the turning points of h. X-coordinates of the turning points of h. X-coordinates of the turning points of h. Right, so the turning points of h are obtained by the derivative. So you note that h is minus 2x cubed minus 7x squared plus 9. And then now you can find h primed of x, which is minus 6x squared minus 14x. Right, so 9 is a constant, so the derivative is 0. You equate it to 0 for the derivative, so in other words, for the coordinates of turning points, you equate it to 0. So you let h primed equal to 0 at turning points. So now, if this is 0 at the turning points, it has certain implications. So you have minus 6x squared minus 14x equals 0. Common factor, minus 2x, which is 3x, plus 7 equals 0. So x equals minus 3 over 7 over 3. So they think determine the x coordinates of the turning points. So there are 2 of them, the x coordinates of the turning points. The x equal to 0 or x equal to minus 7 over 3. The next question is determine the values of x for which h will be decreasing. H will be decreasing. Look at 8.3 now. Okay, to do that one, it's easy. You consider a couple of things. You consider a couple of things. So you need to can draw a basic line like this, the horizontal axis, and draw the axis. So you'd have the x values we just got, and we got 0 and minus 7/3. You start with the negative, and then 0. It's ordering of the numbers on the real line. Okay, now what is the meaning of all these things here? We're going to have this. Okay. Right, so you need to look at the derivatives of this and look at where this is decreasing, where the derivative itself is negative. So a couple of ways to see that one. So the function h is this one given. It is minus 2 x cubed minus 7x squared plus 9, which is minus 6x squared minus 14. So you continue. You continue, and then you look at what happens when x is a number that is on the further right. On the further right. Like if x is the number that is on the further right of 0, can be 3, for example. Okay. So at a number that is further right, what happens? At the number that is further to the right, what you're getting is the following. Right, what we're getting is the following. What do you get? Right, so you'll get a negative. Right, between, for example, between what and what? Between minus 7/3 and 0, you can have possibly, what number can you pick there? Because minus 7/3 is like minus 2. So you can have like a minus 1, for argument's sake. If you put minus 1 there, you're gonna have a negative. And then if you put the other one, you're gonna be, hey, negative throughout. Anyway, no, there's an x here. Just watch out. There's an x there. Okay, because the derivative of minus 7x squared is minus 14x. So let's just look at the sort. Now, okay, this is what you have. So if this is what you have, we continue. Right, so you pick like a 3, which is going to be negative that, and negative that. So surely that is going to be negative. Okay, now if you put the minus 1 there, it's going to be minus 6, and it's going to be plus 14. So it's going to be positive. And then if you pick a number that is further to the other side, maybe like, because this is minus 2, and the third, so you might have like minus 3, which is 3 by 14, negative 3 by 14, which is a positive. What is 3 by 14? Is 30 plus 12, which is like a 42. Okay, so, but now if you say 6 bar is, which is going to be negative, but 6 by 9, okay, so it's going to be actually about a 54. So now, which is negative, and so you are actually See what you're getting there. See what you're getting there, just to be careful. So you put -3, just picking a -3 at random here. So you'd have like a -6 into -3 square that, -14 into -3. And this is 30, which is 42. And then it's -6 into 9. So you have minus 9 by 3, which is -54. Right, plus like a 42. So let's just check this one carefully to make sure we write the correct answers to this. Okay, very basic addition, but you're just always cross-check your arithmetic. We do not desire mistakes, so we need to be very, very cautious of human error. Human error is one of those things that sometimes happens when you and obviously here you see -12. -12. So this is negative. So this is negative. Okay, it's negative. Okay. Right. Okay, we continue. So now you have a negative there. So what is the meaning of all these things here? So you say if it's decreasing, so the function is decreasing here, it's decreasing there, but the function is increasing here. Because this one here is h primed of x. Right, determine the values of x for which h will be decreasing. So it will be decreasing for what values of x? So it will be decreasing when x is smaller than -7/3, or when x is bigger than 3. But than 0, excuse me. X bigger than 0. So when x is bigger than 0, you have that. So, or if you want to say that, you can say when x is an element of the interval, so you have -infinity to -7/3, or x is an element of the interval from 0 to infinity. Like this. Okay. That is the answer. So the values of x for which h will be decreasing. Okay, we found that. For which values, or you can write like this. You can write like x is an element of the interval from -infinity to -7/3 union, which is or 0 to infinity. So in 8.4, for each values of x, will there be a tangent to the graph of f that is parallel to the line this? Okay, let's look at this one. 8.4. Question 8.4. For which values of x will there be a tangent to the curve of h that is parallel to the line this? 8.4. Which values of x will there be a tangent to the graph of h that is parallel to the line? So a tangent to the graph of h that is parallel to the line would have the same slope as that. So in other words, you have y minus the 4x is 7, which means y is 4x plus 7. Now, you have this h. which is h of x is given is minus 2x cubed. So you have the derivative of this. The first derivative for the gradient. So it's minus 6x squared minus 14x. Right, so you're therefore saying minus 6x squared minus 14x is equal to 4. Which means 0 is equal to 6x squared minus 14x. Is plus 14x. We have 6x squared plus 14x plus 4. 3x squared here plus 7x plus 2. 3x and x, 2. 1 and 2 factors are these. Which means x is minus 1 over 3 or x is minus 2. So now they then said determine the values of x for which there will be a tangent parallel to this. So the values of x are 2 of them, namely x equals minus 1/3 and or x equal to minus 2. Right, the next question is question 9 about a sphere. A sphere. So let's look at question 9. Let's look at question 9 about a sphere. Right, in 9.1, a cone with radius r centimeters, and height AB is inscribed in a sphere with center O and a radius of 8 centimeters. OB is x. Calculate the volume of the sphere. The formula for the volume of the sphere is 4/3 pi r cubed, which means the volume of sphere is 4/3 pi r cubed, which is 4/3 pi. What is the radius? The radius is 8 cubed, which is the same as what this you multiply, which is 2048 pi divided by 3. Okay, so this volume can also be written approximately as, so it's approximately 2144.66 cubic units. Show that r squared is equal to this. Show that r squared is equal to that. So to show that r squared equals that, you already know the distance from the center to the circumference is 8 units, or the radius is 8 units, this you know, so you can put it here. Let's look at this next question. So in 9.2, you know that you have something like this, okay? A right angled triangle. Right, so, okay, what is this? Which means 8 squared, the square on the hypotenuse by Pythagoras theorem. It is 8 squared is x squared plus r squared. This is called Pythag, which means it is 64 equals x squared plus r squared. So what is r squared? Which means r squared is exactly 64 minus x squared. Pythagoras theorem. R squared is 64 minus x squared, which is exactly what they wanted us to show, therefore 1 mark. Right, so we continue to do more. In 9.3, now we're going to determine the ratio between the largest volume of this cone and the volume of the sphere. I mean the ratio between the largest volume of this cone and the volume of the sphere, 9.3. Determine the ratio between the largest volume of the sphere, largest volume of this cone, and the volume of the sphere. Right, let's start with the volume of the cone. What is the volume of the cone? 1/3 pi r squared h v of the cone is 1/3 pi. What is the radius? We've already seen that r squared is 64 minus x squared. What is the height of the cone? The height of the cone is exactly this one here. The height of the cone is exactly x plus 8. So, which means the volume of the cone, right, is pi over 3. You multiply out, you open the brackets, you distribute, so it's 5112 plus 64x minus 8x squared minus x cubed. At this point, you're welcome to find the derivative of this. You want to get the largest volume of the cone, find its derivative. So which means the derivative with respect to x is 64 pi over 3 minus 16 pi out of 3 pi out of 3. 0 is equal to 64 16x minus 3x squared, which is 8 minus 3x into x plus 8, which means x is equal to 8 over 3, or x equals minus 8. So what is therefore the volume required? So which means that the actual volume of the cone divided by the volume of the sphere is the third pi, 512 out of 9, 32 out of 3, 2048 pi out of 3. So the volume of the sphere is 2048 pi over 3, and then the volume of the cone there is obtained at this value of x, that is a third. Just substitute. So you get this. Right, if you simplify everything here, it becomes 8 out of 27. And this is actually 0.3. So which means, therefore, the ratio between the largest volume of this cone and the volume of the sphere is 0.3 there. Okay, just note that. Right, so we shall continue with the next question next time. Okay, so we have done something today, and I'm glad that we discussed something because we took a break for a couple of days, so we couldn't discuss. But now we're able to discuss, so we're good. All right, so we shall talk again. I will see you again. I wish to see you soon. Monday or tomorrow at any time of the day, you let me know. I don't know. Okay. So I'll hear from you. All right. You still there? Or I lost you? You still there or I lost you? Hello, hello. Hello. Are you still there or I lost you? Are you still there or I lost you? Thank you so much. See you next time.